We're going to be writing our own C networking server. Well, an HTTP server. Very simple HTTP server. We should be able to get through it pretty quick. I think we should be able to get pretty quick. I'm pretty certain. What do you read HTTP as? Or what does HTTP stand for? Hypertext Transfer Protocol? Right? Isn't that what it is? I should know. I have a whole, I depend on it. Isn't it Hypertext Transfer Protocol? I've got our Linux pages up here, our man pages for our socket stuff. So I was going through that a little bit before stream started, right? Isn't it HTTP stands for Hypertext Transfer Protocol? Hey, all right, there we go. HT, lowercase t, capital case T, and protocol. Hypertext Transfer Protocol. Thank you. Oh, yeah. All right, so let's see if we can get some stuff. So I know we're going to need to include socket.h. I think we need to also include an inet. Here we go. We need to include this as well. So we got a couple of things to include here. And then we can start getting our HTTP server started. I'm excited about this. This is what my whole business is based on. These lines of code that you're about to see are worth so much to me and have done so much over time. I'm really excited about it. It's pretty neat. It's io.h, and then we also need some sockets in here. We need some sockets. I include inet in, probably that. I'm pretty sure, maybe. And then we also need a socket. I'm pretty sure we need a socket. Here we go. It says sockets. Perfect. Here we go. There we go. Getting them in. All right. So here's our networking stuff. We'll be doing some socket programming. Here we go. All right. So what do we need to do here? Let me look over this. All right. So I know we're going to have to define a port and a couple of other things. A socket. There's got to be a method in here. Here it is. This is what we need. We need this. All right. And then we're going to need some of these guys, some of these constants in here. Here we go, right? Socket file descriptor. Perfect. We need this. That's going to have to be that. I know we're going to need that. And then we need a socket family. We need a socket type. And then a protocol, which is going to be TCP probably, right? It's going to be TCP because we're doing an HTTP server. We're going to make it an integer. So this will be the main socket, main entry FD. And then we're going to get other FDs, I think, with a client socket in a different port that we'll be able to accept after we accept it. And then we'll be able to write to that socket. So this is the main inbound. This is the inbound, main entry inbound file descriptor. File descriptor. FD, right? File descriptor. File descriptor, which basically is the I/O part of the operating system. It's gonna be the inputs and outputs where the operating system is gonna read and write bytes from. So I need a bind. We need to do binding next. Bind. Is bind in here? Yes, there's a lot of bind. There'll be some binding and some listening and some closing and things like that. All right, so bind, int bind. All right, so we need to run this. Let's see here. We're going to add this in here. Okay. We also need an address, I think. We're going to have to do that as well. C. We're doing C basics. Obviously, if you want to do it in Rust, you're going to have a better time. Or worse, depending on there could be some challenges. How is an int? Because it is going to be a 32-bit value. It's going to be a number, and it's going to be representing a number that the operating system is going to hand to us. It's like a ticket, like a line. Like, here's your ticket, sir. Use this ticket to communicate with my inputs and outputs. So this is the operating system's ticket. And then we're going to bind on that, on this file descriptor. Hey Joshua, we're building an HTTP server in C. Today is the last day of C basics. We're going to get ourselves a file descriptor from the operating system asking for essentially a socket stream. Then we're going to bind our local address, which is going to be 0000, a whole bunch of zeros. And then we're going to add a port to listen on for incoming and then we'll register new file descriptors, which we can communicate back and forth to individual clients. And that's the plan. We're going to do that. That's the plan for true. Probably like this true, which is wow forever, basically. And we'll eventually break. We're going to be doing, essentially, we need to listen for incoming connection requests. And then we need to accept that request, bind it, read from the socket on the file descriptor, capture the user's request, and then respond. So what is TCP? It's like on the internet, there's Ethernet frames, right? So you got Ethernet frames, which is like the core foundation of the communication, which are packets, little small packets of data that have headers, which describe where data needs to go. And then there's a body section. And that body section is all the text, like all the text that you send. Like you just typed your message. Your message was in the body section. Transmission Control Protocol. Yeah. Thank you, Sivan. That's what that is. It is sort of like a description of how data is transferred. It's a protocol. It's an exchange of information, a system, and a strategy between. All right. So we need a socket address here. All right. So we're going to do this. Struct socket address. And then we need to assign ourselves a socket address. And it's going to be the same socket. It's going to be the same family here. And I think we have to do it like this? Let me double check. No, I had it right. I had it right the first time. Okay. So we're going to be making this, right? Because it's the family, right? The family right here. The port number, we should probably do this. Define port. Well, it's probably like this, right? Lowercase, define port as port. We'll do 8900. There's an easy port. We're doing socket programming, and it's been a little while since I've done this, right? Because once you write it, things you typically work just perfectly fine. And we do port. I think we do port. I'm pretty sure. And then we need to do in address. Let's see here. Where is that? Okay, so basically we're going to use this keyword here in any address, which is essentially this 0.0.0.0. That's what that is. You want to accept it. This is basically we're targeting anything, and we're going to bind on this address. We're going to bind on 0000 on port 890 or 89 or 8900. That's what we're going to do. Typo there. Sorry. Oh, no worries. Hey, we figured it out. Great to have you guys here. I have an obsession with people, right? So we're talking about like IPv4/IPv6, right? So you got those varieties there. Address family. Got to have your address family, guys. Socket stream instead of a socket dgram, right? So you can do dgrams or socket stream. What are we making? All right, great question. We are making a HTTP server from scratch, as you can see here. And we're going through the Linux man pages. So you can see here, we've got our Linux man page right here. I've got it over to the side, so that way I can build it for you. And we're going to make sure that we get it ready and all nice and tidy. It's going to look and it's going to work good. And we've got plenty of time. And we're going to keep it simple. So we also need to bind, we need to listen, and then we need to accept. We need to bind, listen, and accept. So we do accept here, and then actually it's gonna be like this, accept here. Then we're going to bind here, and then we need to listen as well. We need to listen, so that way we can capture incoming requests, essentially, for new ports or new file descriptors. Here, struct, we'll call this our socket address in. Perfect. We could call it whatever we want. We'll call inbound socket. We call that, right? I'm pretty sure, right? All right, we can do that right there. We can do that, and I think we have to do ampersand. We'll do ampersand, and then we need to have size of. We need to do a size of this guy right here. Inbound socket. Okay. Size of. There you go. I think that'll do the trick. I might have to do some interesting things on this. We'll have to find out. Socket ADDR struct. Oh, wait. 1 second. Wait. Inbound socket. 1 second. I need this to be here. 99 redo. Okay. This will be 1 second. ADDR. We'll call it server address. Here we go. I think server. We are building HTTP server in C from scratch. People can't code without AI. Just right. And AI can't code without Steven Hartwired. Thank you. And percent means address. Yes. So we're passing the reference, the address to the structure for the bind, so that way it can read the memory at that location. That's what we're doing. So I believe this part is good. I believe it's good. I might have to do a few things. Let's see here. Let me see. I'm going to comment this out here. Well, actually, you know what? I'll just say break. There we go. We'll say break. Thank you for joining, you guys. Happy to have you here. Well, LT Sun. What are you doing there, Heartwired? That's my first company. All right, so I think what we need to do here is we need to do some casting. Let me double check. Let me pull open my... Oops, sorry about that. I didn't mean to blind you guys. Here we go. All right, I need to cast that as a specific data type here. All right, let's do that. Right here, like that. Wait. Like this. There we go. I think we have to do that. It says it needs to be a sock eder. So, right, see, as you can see right here, look, in my right here, check it out. It needs to be the address of a sock eder. Ah, there we go. And what did we just do right here? What did we just do? We did an address of a sock eder. So we're doing a cast. We're casting it. Because it's the same kind of struct. It really is. It's just slightly different. Maybe port is fine here. What does it say? Implicit conversion from int to saw family. Unsigned char. Oh, unsigned char. Unsigned char. Okay, let's try that. What is that? Int saw, aka unsigned char, changes from 9 to 72. All right, we'll figure this out. We'll make it happen, you guys. I need to include a conversion. I feel like that should work. Thank you for subscribing. Who is that? Having fun on YouTube. Thank you for subscribing. Welcome on in. Const struct socked ender. Thank you. Sockder in. Yep. Sorry, I'm gonna be off the live. Hey, Betty. Bye. Thank you for hanging out. What's the challenge? Hey, we are currently trying to make sure that we get HTON's port, SN port. Okay, let's try. I think we need to include a converter. So let's try that. H2 unsigned char said a simple type mismatch. Yes, the macro isn't catching it, so that's why the error, I guess. Yeah, me too. I think so. Yeah. I think so. Like an hour. Well, we've got 30 minutes. We got 25 minutes. So we do got to get going here. So let's make our way. Let's make our way, you guys. What is here? Okay. Why is this highlighted? What happened? Oh, right. Okay. Right. Okay. Dgrams, let's comment that out. Tuple, address family, struct, bind to listen. So now we should be able to get into the rest of it here. We should be able to get to the rest of it. Okay, we're gonna have another client FD. Do we have the sock? So this is the server FD. What I'm gonna do is I'm gonna change this to server FD, like this. There we go. So that way we know, and then we're gonna have the client file descriptor here. We'll have accept, and it will be accept, and I think we need to just pass in the server file descriptor, or server something here, server FD, yeah. And then we don't need anything else. There we go. Okay, so that should allow us to accept requests. That should allow us to accept. Can run HTTP. Okay, good. Nice. And now all we have to do is read data. We have to read data from this file descriptor. Okay. So this is our, so then we can just send data. I think we can send data, right? Okay, so we should be able to send client file descriptor, and then we need to say, we need to, it needs to be HTTP response headers, right? But let's just send a bunch of text. R back to N. Let's see what that does. That might cause a problem. An HP server use case. HTTP server is a way for you to create an API endpoint that you can host as software somewhere in the cloud or in a rack somewhere, a 1U if you want, in a colo data center. You could essentially make your own API or make your own web server. And that's what we're kind of doing right now. That's what we're doing. Backslash rn, hello world. 1 second. All right, we're running out of time, you guys. We're running out of time. Let me see here. Let me know if I got anything right. Steven is testing in production, I heard. Yeah, we do that sometimes too. We've done it. We don't do it anymore. Looks good. Best of luck, bro. Thank you, Spicy Chips. Still under construction. You got it. I'm actually trying to make a rich presence for Discord. And see, this is so helpful. Hey, nice. You're trying to make it? Yeah. Is accept blocking. It might be. It is. It is. Don't run late. I know. Let's build an IRC. We could. You could build one. Bro, I can make another Linux using C or Rust. Which is, would you prefer? Rust. Goku, do Rust. Make it Rust. So let's see. /rn. Let's see. And then we say 1, 2, 3. And then /r, /n. I think that should be good. And then let's do strlen on that. Although, strlen instead of 14. Is that it? Yes, okay. I still don't think... Uh-oh. What does it want? Too few arguments. What did I mess up? I messed it up. Oh, respond. Okay, got it. Yes. Okay, there we go. Boom. All right.